coordinator. Clear to proceed. You have permission to launch. Proceeding with the count.
おはりやです。みんな、今、打ち上げのGOのGO判断が行われまして、GOフォロー釣れましたので、配信します。
Yeah, that was
ちょっ
great
と待って
to
て
see
ね。
Dylan choreograph that poll, the culmination of several hours of work by this launch team, and then hearing Launch Director Tom Heater from United Launch Alliance giving that ready to proceed for launch today. So very excited and happy here to hear that as we get ready to pick up the count.
今日はさ、アトラスの中でもさ、特別なんですよ、リアにとっては。なんでかわかります？
But we're looking at blue skies. You can see some of them there. They're moving. That's representative of those winds. But as we know here in Florida, it's such a beautiful time of year in March. But Mick, 3 months from now, it'll be the start of hurricane season, which is a concern for Florida and everyone along the Atlantic seaboard and in the Gulf states.
Yeah, and I'll be very happy to have GOES-T up there in the west. As Kevin was saying, you know, all weather moving west to east, so getting GOES-T into proper position to follow those weather activities will be a great asset for everybody from a personnel safety standpoint.
And the public really relies on the public broadcasters who come out and give us that information about what's going on. And we have one of the more popular meteorologists that you may have heard of sent us a pre-launch message. Take a look at it now.
Hello everyone, I'm meteorologist Jim Cantori from the Weather Channel Television Network, and I am so excited for the GOES-T launch. Meteorologists and weather anchors like me across the country depend on GOES data to bring you your daily weather forecast, but also to keep you and first responders safe during severe weather events. Accurate and timely forecasts are crucial, and that's not possible without satellites like this one. Godspeed, GOES-T.
3, 2, 1, mark.
And there you have the syncing up of the L clock to the left top and the T clock on the right hand side. They are in sync, Nick, and that means we are starting up and really close to ready to go.
Yes, this is a very thrilling time for us, Daryl, as we get ready to perform a lot of activities here. The team's going to finish tanking and topping the vehicles, securing everything, getting things to flight pressure, getting the ordnance control unit armed, the flight termination system armed, getting the vehicle on internal power, which we heard a little while ago that the spacecraft GOES-T is configured and on internal power, ready for today's launch. So we'll be finalizing all these steps, the United Launch Alliance team that we talked about earlier, and they will get GOES-T ready for a liftoff at 4:38 p.m.
And there you can see from that shot of the pad out over the Atlantic Ocean, you see down towards the bottom of the rocket, those two solid rocket motors. There's two on this side, two on the other. This is an Atlas 541 configuration, which we know is going to provide a lot of performance with those new GEM 63s.
Yeah, Daryl, the 541, as Tori Bruno, CEO of ULA, likes to refer to it as the Dominator. Those 4 solids will provide a lot of thrust as we get GOES-T off this morning. Using those new GEM 63s from Northrop Grumman will provide a little extra performance and get GOES-T on her way.
You can hear the team really picking up the chatter here as we get down to the final minutes for the launch of GOES-T on board an Atlas V rocket from right here at the Cape Canaveral Space Force Station.
Yeah, Daryl, we heard the team, they secured the Atlas tanks to flight pressures, secured that topping. So we see that the liquid oxygen on board that first stage is secure and ready to go. We should be hearing them at about 1:50, securing the Centaur tanks and getting that tank up to flight pressures, getting ready for launch.
Spacecraft is on internal, getting ready for the vehicle.
遅延があるからね、多分6時39分頃になるかもだけど、一応打ち
155.
上げ時間は6時38分くらいかな。
150.
Securing Centaur LH2. Securing Centaur LO2.
So there we hear Daryl, vehicles on internal. The auto sequencer has taken over and started the count. And Centaur LH2 and LOX sequences are done. Launch has been enabled by the launch conductor.
FTS armed.
The flight termination system has been armed.
めっちゃ言えるって書いて
And the team is continuing to finalize all preps as the vehicle is getting ready for liftoff.
120.
みんな音量大丈夫ですか？
SCS count started. 115.
回復したい。始まりましたね。
Roger. 110. Vent valves locked.
さあ、あと1
There
分
we
です。
hear the vent valves locked, securing everything to secure that boil off.
いや、
We
今
should
日
now
ね、
be
ズーム
coming
オ
up
フで
on
き
the
たんです
last
け
call for the
ど、
range.
1 minute.
Rock, report range status.
Range green.
レンジグ
And there we
リ
have
ー
a
ン。
green range, Daryl, so everything
オ
looks
レン
good
ジ
this
グリーンじゃ
morning.
ないよ。
Last but
レンジ
not
だよ、
least,
レ
we
ン
will
ジ。
bring everything to
あ、レン
flight
ジじゃない
pressures and then
よ。
hear that last status check from Dylan Rice.
And that'll be an exciting moment indeed as we look across the river there to a shot of the rocket. Just a few
40
seconds
seconds.
left.
さあ、あと
Stable at
41
step
秒。
And there we verified that all pressures are good, and we are stable at step 3, ready for liftoff this morning.
28.
Verify ECS reduced for launch. Verified.
25.
Status check. Go Atlas. Go
Go
Centaur.
Atlas! Go
Go
Centaur!
And here we go.
Here we go.
The final seconds now. 10,
10,
9,
9,
8,
8,
7,
7,
6,
6,
5, 4, 3,
2, 1.
1.
Go Atlas 5!
And
う
liftoff. Liftoff of
かっこいいもの。
GOES-T,
Lift
our
off
newest
出た。
weather sentinel in the sky to help keep us safe here
い
on
って
the
らっ
ground.
しゃい。
Daryl, let's listen in as we listen to United Launch Alliance. Rob,
Numbers look good.
Go, 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 go!
View has gone to closed loop control.
まっすぐ綺麗だね。お
The
ー。
RD-180
め
is
っ
now
ちゃ覚え
settling
てる。
down as expected.
シェアリング長い。
We're now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
綺麗ですね。
Seconds.
ブースターつってだけあるんだ。
Passed through Mach 1.
う
Vehicle is
ん、
now
よい
passing through
よ
Mach 2,
いよいよいよい。
maximum dynamic
い
pressure.
ってらっしゃい、うすいちゃん。
Throttle back.
頑張れ。
Now 55 seconds into flight. Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1900 miles per hour. RD-180 is now throttling back up.
We backed off the throttle to
めっ
the
ちゃ、
route
めっ
to
ちゃ
the
嬉しいな。
Atlas
めっちゃ
is
嬉しい
13
な。だって
miles
アト
in
ラス
altitude,
541
10 miles
だよ。
downrange
合
distance,
ってるよ
traveling
ね。
at 2700
541
miles
だ
per hour.
よ。541だよ。もう。リアちゃん。
Come
Now
on,
at 90
just
seconds
seconds.
into flight, ULA's Atlas V rocket weighs now just one half of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
めっちゃ綺麗
In
に。
10 seconds,
下からも燃えてる。頑
solid
張れ
rocket
頑張れ。
motors
だ
on
ん
the
だん
side
が
will
大
cut
きくな
off.
ってきましたね。おー、すごい。
Beautiful
上から
shot
も。オンボー
from
ド
space.
も元気じゃん。めっちゃすごいじゃん。なんか線入ってる、こう、なんだろう。
SRBs have
あ、
burned
取れ
out
た
as expected,
ー。順番
and
取
we
れ
see
ん
a
の
good
スピー。
SRB jettison.
よい順番
Clear
取れ
shot
んの
of
スピ
those
ー。
SRBs.
ボロボロじゃん。すごい。めっちゃボロボロ。え、面白い。え、ボロボロじゃん。
Here in a few seconds, we're going to throttle back
綺
up.
麗なコロラブクロスとかで違うね、なんかね。
Now
ポロポロポロ
135
ポロ。
seconds into flight.
うわー。バラララララって感じかな。うおー、楽しい。頑張れ、スイちゃん。もっともっと飛ぶんだ。あ、でも、
The RD-180 has
4も
throttled
ない
down
から、
slightly.
ういちゃんかな。ブースター4つ伝えたから。
Vehicle performance continues
頑
to
張
look
れ、
good
う
at
い
this
ちゃ
time.
ん。
Tank pressures are stable, and Atlas booster battery voltages remain in their expected ranges. Now the upper stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels.
セントーレアクターシステムセンプレッシャーって言ってるね。セントーレっていうのは、この今飛んでるやつじゃなくて、この中に入ってるやつ。あれ
Now
こ
we
れか、これ
jettison
今飛んでる
the
やつか。
payload fairing, which
違う違う違う違う。
protects
この中に入って
GOES-T
次のやつで
at
す
3
ね。
minutes and
次
30
のやつ
seconds.
が多分セントールで、そこのリアクションシステムに開発中
With just over 1 minute until BECO,
そろそろブースターの
we're
片
now
付にな
seeing
るかも。
the RD-180 throttle limiting to maintain a 2.5G acceleration limit. Standing by for payload fairing jettison.
何段ですね。何段なのは知ってるんだけど、今つってるのは1だよね。取れたフェア
And
リ
we've
ング
seen a successful payload
1
fairing
個は見え
jettison.
たけど、もう1個はちゃんと見えたかも。見て
Good
ない。
shot
なん
of
か丸い
those
のも取れ
fairies.
た。セントールのフェア リングとの間のリングですね、あれ。
RD-180 is throttled back up now.
フェアリングがあって、セントールが真ん中に入ってるんだけど、フェアリングの中にちょっとだけ。そこのとこについてるこの丸いリング。めっ
The
ち
vehicle
ゃ
has
綺
reached
麗
a
に見えたじゃん。
4.6
すごい。
acceleration limit and will maintain this
そ
level
う。
through
これ
Pico.
が衛星ちゃんで、こ
And
う
you're
さ、
looking at animation
あ、
now.
消えちゃった。
We've seen that
こ
the
の衛
Centaur
星
has
の下
begun
に
its
ね、
two-stage
ちょっと
children
台になっ
sequence.
てるんだけど、あれがね、セントールのエンジンの一部のはずです。あそこと、フェアリングをつなぐ丸い板もよく見えたね。すごい。こんなに見えたっけ、アトラスって。嬉しい、これ。
And
すごい。
Pico, booster engine
ア
cutoff.
トラスってこんなに見えたっけ。
Standing by for stage
さあ、分
separation.
離。
And
分離も見える
successful
ぞ。
stage
うー、
separation
す
event.
ごい。いってらっしゃい。
We've seen pre-start on the RL-10.
ちゃんとこの排気まで見えるぞ。これ、すごい。
And Mass 1, we have ignition for the first burn.
バ
This
イ
first
バイ
burn
バ
of
イ
ULA's
バ
Centaur
イバ
upper
イ。
stage will place the GOES-T spacecraft into a parking orbit around the Earth. This
めっ
burn
ち
will
ゃ
last
す
just
ご
over
い。こ
7
んなに見
minutes.
えたっけ、アトラスって。
What a shot there, huh, Mick?
Yeah, that was great, Daryl, to see all that and listen to
めっ
Rob
ちゃ見え
Kesselman
るじゃ
call
ん。
that flight.
嬉しいやつじゃん、これ。
First stage
はい、セン
performed
トール
very
に切り替
well
わりましたね。
this
こ
afternoon,
いつ
and
がセントール
everything's
ちゃん
looking
という
good.
ロ
Those
ケッ
Gems
トエンジンです。
Control
太
system
陽
as
か
it
な
begins its periodic
クラウ
firing
ス
to
テージと
maintain
も言わ
thermal
れたり。
control
よ
conditioning.
くある2段目かっこ
Yeah,
上
those
段
Gem 63s
のエン
performed
ジン
well,
です。
solid
こ
rocket
の子で
boosters, and
衛星を
RD-180 performance
購
well.
入する
What I
よ。
really liked was when we saw the
こ
payload
の状
fairing
態の
come
こ
off.
とは
That
もう
was
セ
a
ントールっ
great
ていうの
shot
みた
from
い。
the
なんか
camera.
アトラス
Saw
って
the
いうの
payload
は
fairing come off, and then
セン
most
ト
people
ール
probably
みたいな
noticed that
ね。
little half cylindrical come off after
Half
payload
ring,
fairings.
yeah.
That was what we call the
わ
Centaur
あ、めっ
forward
ちゃ見え
load
た。
reaction deck.
しかもカメラ
Because the
し
fairing,
っ
the
かり
5
映
meter
ってて
fairing
エロく
encompasses
ない？
both Centaur
めっちゃすごかった。あ、
and the
これもす
GOES-T
ごいさ。
satellite. There's a load ring that's inside the fairing around
燃えて
Centaur
ん
to help
の？
keep that
The
5
engine
meter fairing
propellant
from
utilization
flexing.
system has gone
So
to
that's
cruise.
what you saw when you came
炎
off there.
見え
The
ない。
engine response remains nominal.
こっちは見えるけどさ、ね。
And so
Word from the trajectory and performance group that
シ
booster
ーサの
performance
炎は見え
was
ないってやつ。え、ほん
as
と？
expected
こんな
for
に
the
見
booster
えない
phase of
の？
flight.
all right, we're going to keep an eye on this burn and listen in. But in the meantime, we'll send it back to Megan out at the host desk.
If you're
これ
just
は
joining
なん
us,
か反射
welcome
してるの
live
か
to
な、この
Kennedy
辺とか
Space
って。
Center
なん
in
だ
Florida,
ろう
where we
ね。
just saw GOES-T launch from just behind us at Cape Canaveral Space Force Station. And guess what, everyone? I
す
just
ご
found
か
out
った。
that this was
すご
Kevin's
かっ
first launch.
It was.
How was it?
It was super exciting. Almost a proud moment as an American, 20-year Air Force
さ
vet,
あ、
and to be able to see
この
this
セン
was
トールのこと
was
が
awesome.
一応なんだろう、メインステ
Yeah,
ー
I'm
ジ
so
みた
glad
い
to
な
be here.
扱い
It
を
was
している
very fun to
んで
watch
すよ
you
ね。
react.
ア
Like,
ト
you
ラ
know,
ス
like
って。
I
な
did it
の
like a
で、
kid. Like,
Like a
この
kid.
子の
oh, wow.
。I
It was
was
great.
absolutely.
It was great. So what's
つい
next
た
for
り
this
消えたりする
mission?
のは、
Well, the
セ
wonderful thing
カンド
about
ステ
this,
ージ
now
イ
that
グニッショ
we've
ンと
had a
か言わ
successful
ない
launch, we have about 12 days
なんか
before it
こ
actually
う、
reaches geostationary orbit.
こんな
So at
感
that
じだ
point,
し、メイン
that's
エ
when
ン
we'll
ジ
start
ン
our checkout phase. We'll be
ス
looking
タート、
for
メインエ
the
ンジン
data
カ
to
ッ
come
ト
down
オフ、
from
メイン
the
エ
spacecraft to
ン
make
ジン
sure
って呼
everything
ぶんだっ
checks
て。
out, that the images are correct, all that kind of stuff has to work its way through.
And, GOES is NOAA's latest weather satellite, as we've said. We've been launching GOES satellites together for nearly 50 years. I mean, there's been so many advancements made in between those times.
There have, and I like to remind people that this particular satellite in the series is really an evolutionary step, much like cell phones. Or when we talk about, hey, do you remember when we used to use landlines and rotary phones? Well, think about the leap we've taken from then to the cell phones and the capabilities that we have, much like that with our satellites.
Yeah, I know. I feel safer knowing that GOES satellites are up there. And now I'd like to bring in NASA's Leah Martin, who got to watch the launch with our agency's deputy
こん
administrator,
なに見え
Leah.
ないものなのね。
Hi, Megan.
モ
Like
デル
you
フ
said,
レ
I
して
am
た。
here
え、
with
見
Kim
逃したか
Milroy,
も。もう一回
NASA's
見た
deputy
い。
administrator. And what did you
見
think
放
of
題や
that
んけ。
launch?
ほ
So
んとね。
exciting.
ほんとだ
It
よ。
was exciting, and it was, I don't know, I always just feel this electricity when a launch goes up. You're like, wow, people can do this. This is just the power and the majesty of it as you see it lifting into the heavens. It's always
I
exciting.
miss the
And,
ghost launch.
hours and hours and months of work that go
Yes.
into
Not
it.
miss it.
Absolutely.
You
So,
are not late.
NASA's vision is to expand knowledge
You
for
are
the
not
benefit of people here on Earth. That's the heart behind everything that we do. How does this mission fit into that?
こん
this mission is a great example of
バラバラ
our
じゃん。
mission.
次の
In
海
a
岸か
lot
な
of
あれ
different
海岸だ
ways,
ったん
I
だ。
think
な
one
る
of
ほ
the
どね。
most
よく見えてな
powerful
かったよ。
things that we do at NASA is we partner with others to maximize the benefit of the things
お
that
ー
we
よかっ
do.
たね。ちょっ
So
と、じ
this
ゃあ
mission
次のカット
to
オフと
launch
か
the
の
GOES-T
タイ
satellite
ミングとかもちょ
will
っと。
enable us to have cutting edge capabilities that are looking down on the Western Hemisphere, the western part of the United States, to ensure that the data that goes into the NOAA models around weather are optimized, they're up to date, they will affect people's lives, whether it's farmers or protecting from wildfires. But what's interesting is we're also going to take that data because we have Earth scientists who are modeling our Earth as a system and climate far out into the future. This isn't an operational weather, which is what NOAA's mission is. They do it very well, but we take this data and we also use it for the benefit of science. So it's a really synergistic partnership.
And you just mentioned climate change and monitoring the changes because that is a priority for NASA.
It is. It's one of our top priorities. We are already doing a significant amount in this area. Earth science and looking at our own Earth has always been an important part of our science mission. Interestingly, we also study other planets in the solar system, such as Mars, which we believe was once wet and had more of an atmosphere. And so the question is, how did it get the way that it did? And how do we make sure that does not happen to our planet? So it's a critical part of our mission.
Well, we're hoping that the information that we get today can feed into the future missions of tomorrow. If nothing else, we'll certainly know the weather. Pam, thank you so much for joining us today. We really appreciate it. Thank you.
Exciting day.
Megan, back to you.
Thank you, Leah and Pam. And Kevin, GOES-T doesn't just forecast the weather. We've talked about this a little bit. You know, we've talked about how it monitors the atmosphere for fog, dust storms, and smoke, and you know, especially for wildfires. But what about like smoke and ash for volcanic eruptions?
Yeah, absolutely. This past year has been kind of a revelation in our capabilities to view volcanic eruptions. In particular, probably the most spectacular example would be the Tongan. What we also have is another example in the Caribbean where you can see not only the amount of ash that goes up, but the area that it covers. And as a result of that particular hazard becomes an aviation hazard in particular.
Yeah, you can see all the smoke there, you know. Weirdly enough, 2 years ago, I was traveling in the Philippines, and there was a volcanic eruption there, and we had to ground hundreds of flights because of it. So really, GOES helps decide whether or not it's safe to fly.
They do. Again, NOAA's partnered with the FAA, and they provide them with those volcanic ash, both forecasts and projections for where that ash could go.
All right, we're now approaching another milestone in the ascent. Daryl and Mick, back to you.
Thank you very much, Megan, and we continue to burn, continue to get good numbers as we monitor the flight of the Centaur and GOES-T.
Yeah, things are looking really great on this flight, and coming up on MECO 1 of that Centaur engine as Centaur continues to perform nominally. We've heard pressures and everything look great.
The system has gone open loop.
Here in about 10 seconds, we'll have the
Standing by
cutoff.
for the end of the burn. And we have MECO. Main engine has cut off.
There you go. That completes that first burn. And so now we go into about an 11-minute coast phase, Mick.
At this time, the GOES-T spacecraft and ULA's Centaur upper stage are in an unpowered coast phase that will last approximately 11 minutes. The coast allows the vehicle to move to optimal orbital position in the orbit prior to beginning the second main engine burn.
And what you're looking at is animation that is tied directly to the telemetry we are receiving from the rocket.
Yeah, the team is using all the vehicle telemetry to look at and
The reaction control system is operating at the 100% settling mode at this time.
Power this animation that we're seeing, which is really good. And as we heard Rob Kesselman say a minute ago, this approximate 10-minute coast, we're in this park orbit around Earth right now as we coast around to get into the proper trajectory we want to be for that second burn, which will then send us on our way towards that geostationary spot we want to be. It'll be a longer burn, and then we've got, Daryl, that long 3-hour coast that we're going to wait around for.
3 hours, folks, between the points on the bottom of your milestone list, between MECO 2 and MES 3, That's 3 hours. It's short there on your screen, but it's a long one. As you're looking at the animation, we are in orbital darkness. The sun is blocked out, and so the animation is reflecting that at this time. So we can't see the Earth behind it. They give it that kind of accuracy in terms of its look. So the spacecraft is in total darkness, but when it comes out and those solar rays unfurl, it'll have some power. All right, we're going to send it back to Megan for now and while we coast, but we'll be back for that second burn.
Thank you both. Now, GOES-T will warn us about weather here on Earth, but also space weather. But what is that, and how does it impact us here on the ground? Take a look.
So the sun, looking here from the ground, seems very constant and quiet. But actually, when we look at it from space, we can see it's quite turbulent and active. Space weather is activity on the sun and in the near-Earth space that can affect our technological infrastructure and society. The sun is constantly spewing out a stream of particles called the solar wind that goes out into the solar system. And it affects us here near Earth, where we're protected by a magnetic field. The interaction between the solar wind and the magnetic field can cause space weather. The Carrington event is the largest storm we've seen in recorded history when we're looking at space weather. But every solar cycle, which repeats about every 11 years, one estimate estimates that there's a 10% chance of getting a large storm like the Carrington event that could impact us here on Earth. But we see solar storms almost all the time. And these solar storms have an effect on our technological infrastructure. Solar storms can cause activity in Earth's atmosphere and magnetosphere that can damage electrical power grids that power our communities, interrupt radio and satellite communications, and can cause our GPS navigation to fail. NOAA is working with its international partners to ensure that we have different vantage points where we can observe space weather. Our space weather observing infrastructure from space includes the NOAA Discover satellite and the NASA ACE satellite that are stationed upstream of Earth to give us a first buoy measurement of the solar wind. That can tell us when large explosions happen off the sun.
Circle.
In McEwen, Tennessee, less than 12 hours. And so we were able to use GOES satellite imagery to monitor the intensity of these storms and watch how they just trained over the same location over and over and over, and able to, alert emergency officials that rain wasn't going anywhere.
The last time that Tennessee had an extreme flooding in many areas, of course, understand.
Launch. Meteorologists and weather anchors like me across the country depend on GOES data to bring you your daily weather forecast, but also to keep you and first responders safe during severe weather events. Accurate and timely forecasts are crucial, and that's not possible without satellites like this one. Godspeed, GOES-T.
3, 2, 1.
To finalize all prep.
よし、箱を出しておこう。ちょっと待っててね。NASA もね、サイトにね、書いてるから見てくるね。いて。ここだ NASA。てっててっててー。よいしょ。これを。GOES-T をどんなやつか出そう。見てかわいい。ごめん、なんかさ、マイクぶつかっちゃうことあるから、大丈夫これ当たっちゃって。問題ない。音うるさくなかった？ごめんね。よいしょ。ちょっとこれを、リアを出すけど。
steps as the vehicle is getting ready for liftoff.
はい。GOES-T をどんなやつか見てもらおうかな。
Launch will be a polar orbital, which is fundamentally different from what we launched here today. So this, we call it a geostationary satellite. As the name implies, it's Earth synchronous. It actually follows around and looks at one spot on the Earth, if you will, and then the JPSS launch is we call it a sun synchronous. So it actually stays at a certain sun illumination and does orbits around the pole many times to give us a different look at the Earth as it's spinning on its axis. And you take the JPSS satellite data and the geostationary
そこにリア要素を入れたくて、だから衣装もね、いつものスタンダードリアリーなの。スタンダードリアリーの水色と白のバージョンでやったらロケットの宇推なんじゃないかと思って、宇推のロケットだと思ったからこれ作ってきた。
being able to forecast weather, say, 2 days ahead versus a week ahead, and if you've got multiple views of the planet, you can start getting a much better handle on when hurricanes are forming, where they're forming, how intense they are, or things like atmospheric rivers forming way out in the middle of the Pacific. When will it arrive in the Pacific Northwest? So having these multiple ways of looking at the Earth gives us a lot more information for these critical forecasts to save lives, protect property, and basically protect our American public from these natural phenomena.
Now, and the system that is currently on orbit is set, I believe, to go through the 2030s.
So we've called this series the GOES-R, the Geostationary Operational Environmental Satellite R series. There are 4 of them. We've launched the 3 here today. And after this series, we're looking at what we call GeoExo, Extended Observation. So what does the next generation of geostationary satellites look like? What's the newest technology we can put on there? Are there different phenomena that we can look at in the Earth system, but also out at the sun, for example, to understand what's happening with solar storms that impact us here on Earth as well.
So really it's science for today while we're facing forward to science for tomorrow.
It absolutely is. You think about how many years it takes to build a satellite like the GOES series, and you want to make sure that you're putting the state-of-the-art science and technology in the satellite that may not launch for 5-10 years. So what do we think the scientific capabilities will be in 5 or 10 years? And let's start working in the laboratory now to build those new sensors and those new operating systems.
画面の右のこの右じゃないね、リアが右にいるから、画面のみんなの真ん中ぐらいか、右手あげるか右かと思った。右のこれ、右じゃないって。ここのこれ、このGOES-Tちゃんもこれらしい。こんな感じの見た目してるんだって。結構銀が多い。
We sure are, and thank you, Megan. Back inside the Atlas Spaceflight Operations Center, Nick Whitman here with us, LSP engineer. We're heading towards orbital sunrise. We've been in a coast phase right now, heading over Africa, West Africa, across the southern coast there, and we've got a burn coming up in just about a minute.
Yeah, the second burn's very important as it'll get us out of this park orbit around Earth and get us on our way towards that geostationary orbit we want to head for GOES-T to allow them to do their science and protect us with all those instruments they've got for weather realization.
You're looking at animation now tied to real-time telemetry, the Centaur on the left part, and GOES-T on the right part, as it chases the sun, chasing orbital sunrise here in just a few seconds, and basically simulating that with the lighted landscape.
3回目と2回目の間のことっぽくて、1回目と2回目の間は20分だけど、その間が3時間あるよって言ってたみたいでした。リアが時間間違っててごめんね。勘違いしました。なんかめちゃくちゃ眠くてぼぼーっとしてるのかな。失礼しました。これさ、ちゃんとさ、排気までしっかり言ってってすごくない？あ、着いたー。着いたよ。
Number 2, we have advanced across
Main
the bottom of your screen. We have all the milestones listed. We're going to burn for about 6 minutes. As you mentioned, Mick, this is really hitting the gas and getting out deeper into space.
Yeah, absolutely. This is going to be the burn where we get GOES-T headed out where it needs to be, and then we'll coast for that 3-hour period to get where we need to go, and then get ready for separation. So still a lot to go from here, but this is a very important burn for the mission.
Going deeper into space, approximately 22,000 miles away from the surface of the Earth. Mick, I want to take you back. Of course, we know that this satellite here can have ability to map lightning. It's got high technology on there that's very valuable. But also, when it was on the ground, it could have been suspect. It could have been suspect, rather. I should say susceptible. Sorry, susceptible to lightning when it was on the ground. But Launch Services Program developed some technology to help protect it, and I was fortunate to go out to the pad. This is something that you do a lot. Go out there to the launch pad, but I was invited to go out with one of LSP's young
on Earth and get us on our way towards that geostationary orbit we want to head for GOES-T to allow them to do their science and protect us with all those instruments they've got for weather realization.
You're looking at it could have been landscape.
これ見えるこのさ排気かなロケットのなんかその横の排気のやつまで綺麗に出ててさすごいと思ったほら
There we hear pre-start on the RL-10 coming up from Rob Kesselman. Data showing that RL-10 is getting ready to ignite for this second burn.
Locks pre-start on the RL-10?
ここまで出てるんだよこれほらこれ立ち上げの瞬間の多分最初の未燃というか最初つく前のやつ出てるやつもあれちっこい出てるほらすごいちゃんとしかもさ広がり方もさこうふわーって広がっててさいいですねとても良いですねすっぴいですこれ細かいすごい
All right, main engine start number 2. We have
all the other lightning detection networks in the area.
そういう感じなんだ。
So what happens if
6分の間にも番組突っ込んでくる系なんだ。なるほどね。
So if long the transient lasted, we'll be able to calculate how much energy traveled through there.
エレクトリックエナジーとか言ってたら雷かな。6分の間にもあれですね。番組突っ込んでくる系なんですね。これは。おー、了解。理解。
So we can see those lightning towers out there, and NOAA tells me that protects the rocket when the lightning strikes. So why do we need the PLI?
Yeah, so this system over here, we call that the lightning protection system. That's designed to protect it from a direct lightning strike. That means the lightning is attaching directly to the rocket. And we're concerned about, a lightning strike out there in the ocean, maybe, just a mile away. And the energy in a lightning strike is so intense, it creates these very powerful magnetic and electric fields. And those are the things we're concerned about, because that magnetic field can come through and couple into the umbilical cable. It's a huge loop. It makes a big old loop, and that's the current we're looking for with the PLI.
Has the PLI ever prevented a long launch delay for a previous mission?
Mars 2020 was where the data from the PLI gave the spacecraft team the confidence to go ahead and launch.
So there was a lightning strike around the Mars Perseverance rocket.
That's right.
And you saw it?
And we gathered that data, yep.
And it launched on time.
It did. And it's up there now.
That's right, on Mars.
That's right.
Well, that was a lot of fun to go out there, and Alex, of course, was great to have me out there at the pad. But this technology, I mean, really helpful when you have a lightning strike. It was connected up inside the VIF when GOES was inside.
Yeah, Alex and the team done a great job with that. They've been studying this for years, and they came up with this PLI work and working with our commercial partners, they've been able to install it, like you said, on the VIF for the Atlas V mission. And as Alex mentioned, we actually used it during Mars 2020 to help us verify some information, so we didn't have to go back and retest anything, and it actually saved the launch from delaying. So, the hardware is great for what we have involved in it.
Especially important for a planetary window like Mars, where you only had so much time to launch to make it to the planet. But we are in the midst of a 6-minute burn. We're about to wrap that burn up in just a few seconds. You're looking at animation of the Centaur upper stage. You're also looking at GOES-T spacecraft as represented by animation. Just a few seconds left in this burn.
And we have MECO 2, second stage main engine cutoff.
And there you go. We have completed the second burn. Really
is now operating at 100% settling level.
Really got away from
calculate how much energy travel through there. We'll have a lot more information to work on. But it's got a big role in the whole scheme of things. It's got a big job, that's for sure.
Window like Mars, where you only had so much time to launch to make it to the planet. But we are in the midst of a 6-minute burn. We're about to wrap that burn up in just a few seconds.
You have gone to open loop control.
You're looking at animation of the Centaur upper stage. You're also looking at GOES-T spacecraft as represented by animation. Just a few seconds left in this burn.
And we have MECO 2, second stage main engine cutoff.
There you go. We have completed the second burn. Really
is now operating at 100% settling level.
Really got away from the Earth, and now we're cruising pretty good speed away towards that stationary point where they want to get that geostationary orbit.
Yeah, this is the moment we've been talking about a little bit, right? This is that 3-hour coast that we're going to have Centaur and GOES-T do their thing, head out towards that geostationary where they want to get to, so we can have that third burn of the Centaur. And what we'll see on that third burn, Daryl, is that after that 3-hour coast, Centaur will go through its process again of pre-chilling the engine, doing some things to get ready for that.
Centaur is now entering an extended duration coast phase. This coast phase will last approximately 180 minutes. Where we'll have
for that final
third burn prior to spacecraft separation.
Yeah, so we've now flipped the bottom of our progress bar to a countdown clock to show you and represent that 3 hours. When we return, we should be out of Africa and near the coast of Australia. So we're going to do some cruising.
Yes, we are. This, like I said, longest part of the mission, but very much needed to get GOES-T where she needs to be.
All right, for now, that's going to wrap up our coverage for this initial part of the mission. We will be here throughout, listening to the loops, monitoring the launch team. Mick's not going anywhere either. He's going to lock it down, and of course we'll give you all the updates as we go along, and then rejoin you finally after 3 hours. But for now, we'll send it back to Megan and Kevin.
Yeah, as I just mentioned, GOES-T will now coast for about 3 hours before spacecraft separation. We will stay on air for this coast phase to bring you those live animations you've been watching, as well as commentary from Daryl and Mick. You can expect those hits at the top of every hour at 6 and 7 p.m. Eastern Time. In the meantime, we have some fantastic art to show you from kids around the world as part of NASA's Space Place Art Challenge, where every month we invite kids to draw something space-related. And in honor of GOES-T's launch today, we asked kids to draw GOES-T observing the weather where they live. And then at 8 p.m. Eastern, Kevin and I will be back to cover the rest of the mission, so set your alarms, and we'll see you back here soon.
See you then.
GOES-T is って書いてるとこから読んでもらえたらいいと思います。英語ができなかったら翻訳機を使ってください。もしくは、今から読みます。NOAA's GOES-T is the solar satellite in the GOES-R series, the Western Hemisphere's most sophisticated weather observing and environmental monitoring system. The GOES-R series provide advanced imagery and atmospheric measurement, real-time mapping of lightning activity, and monitoring of space weather だそうです。わかりましたか？難しいNOAA's GOES-T is the third satellite in the GOES-R series だそうなので、NOAA さん、さっき言った米国海洋大気庁の GOES-T というこの衛星ちゃんは GOES-R シリーズの3番目の衛星になります。はい。で、The Western Hemisphere's most sophisticated weather observing and environmental monitoring system。ここは、ウエスタンヘミスフィア、西半球っていうちょっと聞き慣れない言葉なんですけど、ヘミスフィアが半球で西なのでウエスタンヘミスフィアです。西半球で most sophisticated 最も洗練されているウェザーオブザブリティの気象観測、そして環境観測衛星です。なんでまとめると、 えると、NOAA のGOES-Tは西半球で最も洗練されている気象観測そして環境観測のシステムの GOES-R シリーズの3番目の衛星ですのが多かったけど、そんな感じですね。はい。で、この後ろに書いてあるんですけど、さっき雷のね話があったと思うんだよね。飛来心の話、あれと多分この衛星が関連してるから飛来心の話をしてるっぽかったんですが、The GOES-R series provide advanced image and atmospheric measurement real-time mapping of lightning activity って書いてます。ライトニングアクティビティってライトニング多分雷なので雷のことも見れるっぽいかな。できるのは高度な画像の撮影、大気のアトモスフェリックメジャーメントだから大気の測定かな。大気の測定、そして雷の活動でいいのかな。ライトニングアクティビティ、雷の活発な活動の、リアルタイミングマッピング、地図上に今雷こんな感じですよっていうのをマッピングできる。そしてモニタリングオブスペースウェザーって書いてある。宇宙天気も見れるみたいな感じのことがいっぱい書いてます。はい。なんでもう地球表面を見て観測する衛星なんですけど、環境観測もする、大気観測もする、そういう感じの衛星になってます。米国海洋大気庁の衛星 GOES-T、GOES-R シリーズの3番目の衛星らしいです。マナーベイさん、モーニターの注目度が低い。待って、読めなかった。マナーベイさん、ノーニターの注目度低くて悲しい。注目度はそんなに確かに日本で騒がれるほどじゃないかもしれないけど、今はね、ちょっといろいろあるからね。はい、この辺から見ていきましょうか。リアのよし、どこだ？はい、アトラス5、4、1 GOES-T 打ち上げ。みんなもこれ5、4、1テンション上がんなかった？リアは上がったよ。だって薄いだもん。いやー、これは嬉しいですよ。リアの名前、ほぼね、リアの名前が入ったロケットを見ることなんてありますか？めちゃくちゃ嬉しかった。541だよ。だって541。薄いじゃん？薄いじゃん。だって。嬉しいよ。ね、嬉しくない？もっとね、みんなが見やすい時間帯にやってくれてたらもっともっと騒げたと思うんですけど、ごめん、朝からごめんね。リアも眠くなってぼーっとしちゃってるけど、これだけは言いたい。アトラス5の541なんだ。541ってリアがずっと薄いって使ってた名前の541だから嬉しいですね。やっぱ数字で541、これ他にまたうちがあったりするのかな。541の語呂合わせが薄いのは、一応中国語なんだよね。中国語なんですけど、5 is in Chinese and 4 is で、1 is in Japanese 1なので、1 5 4 5 is 4 is and 1 is 1なので、薄い薄いです。薄い541 is 薄いですね。すごい嬉しい。なので今日はリオはこんな感じでリアらしさを残しつつホワイトを入れた衣装みたいな感じで、ちょっとロケット準拠じゃない感じにしちゃったんですよ。ほら、あんもいっぱい入っててかわいいふわふわなお衣装になりましたね。GOES-T のメインのやつがこんな感じで、雷入ってるので雷がよく見える衛星であることが書かれてますね。バリバリバリバリ。雷打ち上げの時とかにもやっぱり邪魔だし、宇宙天気の観測もできる、太陽フレアの観測もみたいな感じの映像も出てたので、そういうことを全部ね見れるタイプの衛星ですよっていう、この1枚にギュッと詰め込まれてますね。背景が宇宙で、そしていろんな色がついていて、フレアのそういうのも出てて、あとこの後ろのこのビリビリビリビリのライトニングマッピングができますよっていうのも全部ね 書かれてます。こういうの作るとすごいよね。かっこよく見せるしさ、しかもこんな意味もちゃんと含まれてて、よく見るとよくできてんなーって思えるので、こういうね1枚見るのもすごい好きです。なんかこういうなんだろう、アート、打ち上げのローンチアートでも言うんですか、そういう打ち上げのねためのアートも見逃せないかなって思います。この間のストリックスアルファもね、ストリックスベータもね、ストリックスアルファちゃんとベータちゃんが飛んでるような感じのフクロウさん2羽のねアートになってましたし、結構ね意味深なこと書かれてたりして面白いんですよ。こういうのぜひとも見てみてください。リアが一番最初に配信したあれシーズンのちくわのやつ、データヘビちゃん、あれもね指輪物語の後ろのいっぱい書いてたりとかして、結構作り込みが激しかったので、この作り込んでる人がいるんだなっていうところをこういっぱいじっくり見ていきたいですよね。これのかっこいいからこの時のためだけに作られたこのアート、とても良い。はい、じゃあGOES-Tの次行きましょう。GOES-T打ち上げですね、USEになってます。あとは5です。打ち上げ日は今日ですね。現地時間だと昨日になってますけど、打ち上げ時間は2日です。打ち上げ時刻日本時間で6時38分に打ち上がりました。現地は16時なので、夕方頃でしょうか。結構明るかったのでね、まだ見やすかったですね。打ち上げ場はケープカナベラルスペースステーション、みんなよく一番見てると思います。ケープカナベラルの打ち上げ場、そして打ち上げ場がね ULA の打ち上げ場になるので SLC41 番になってます。スペース X とか40番とか使ってるけど、隣のね SLC41 番ってところで打ち上がってますよ。でアトラスちゃんの名前、今回ねアトラスはねいろんな形態変化ができるんですけど、今回は541というやつでした。541というのはフェアリングが5の5メーター級のフェアリングを使っています。そして4っていうのがブースターの数ですかね。1個じゃあ4個つけてます。そして1っていうのは中に入ってるセントールエンジンの数ですね。これねいっぱい形態があって選べてカスタマイズできるんですよ。フェアリングがね5と4が選べて、2個目のねブースターが4とか3とかもいけるし1もいけるし、あと5までいけるのかな、なんか551とかそういうのもあって、551だと豚まんですけど、541なので今日は薄いの日ということでとっても嬉しいロケットになりました。1っていうのはさっきも言ったけど、ファルコンじゃないやスター、待って、ファルコンじゃない、なんでファルコンって言った？セントールです。セントールのエンジンの個数で、あんまり最近2っていうの見ないよね。これ541っていうのが5段とか1っていうのは結構多いと思います。この間441とかね411とか打ち上がってたかな。あと551は本当に多いです。一番最大のやつ、このアトラス5の中でも最強クラスみたいなやつはね結構違ってますね。541はなかなかない。リアも初めて見たんじゃない？みんなと一緒に541。じゃあ次、シストランスファー軌道に打ち上げますということです。地球全体を見たいので、地球全体見られるまで遠いところに行ってます。地球全体でシストランスファー軌道っていうのは静止軌道に入れるための軌道なので、最終的には静止軌道に投入されるはずですね。高度約36,000キロあたりに静止軌道っていうのがあって、そこまで行きます。おはよう、ありがとう、おはよう。朝からロケットの話大変。高評価グッドありがとうございます。怖いじいちゃんありがとう。もしかしてみんな日本に来てなかったりするの？日本語で開発してたら分かりづらいのかな？ Hello みんなどこから来た？ Hello いない？コメント欄の皆さん、イングリッシュの方がいいですか？いや、イングリッシュそんな喋れないけど、イングリッシュの方がいい？ understand Japanese? 無理。外国日記いるのかな？日本日記？何人いるんだろう？ Words? We are still here. Ah, thank you. My Japanese is difficult. 難しい。We hear you. Oh, well, thank you. We hear you. Thank you. Hello. English で話した方がいいかな。たまには話したいんだよね。Atlas 541 is my name is Usui, so 541 is my name. The rocket goes to geosynchronous orbit. シストランスファー軌道です。The satellite launch. なんていうのこの車上のことなんていうんだっけ難しいね。You always forgot to put the English rocket text on the screen. Wow, I forgot it. English, okay, I understand easy English, so you can comment English. Okay. Nice. Where? Okay, where are you? どこに行っちゃったんでしょう Where are you? Where is my English? Okay. Copy. Paste. Okay. English okay. 貼っときました。Okay. Okay. I am Usui. Okay. YMCA. 力がなさそう。そう疲れてはいるけど力なさそう。そんなに？じゃあ顔変えてください。アンパンマンなので顔が濡れて力が出ないので皆さんの力で顔を交換してください。バッテリーホールドスワープ。アンパンマンに新しい顔よ。力ないマジで。そっか頑張るよ。じゃあ次行きますよ。はい、ケープカナベラルの SLC41 番っていうのはここなんですけど、いつもねたまに出てくるスペース X の打ち上げ施設がこっちの端っこの上の方にあるはずですね。このぐらい、これがスペース X のやつで、こっちが ULA のやつです。でここに海岸があるの。さっき海岸見えてましたよね。はい、GOES-T NOAA 米国の海洋大気庁の気象観測衛星のGOESシリーズの3号機に当たります。近い何？お家から近かったりするの？で前のGOES-17でちょっとなんか問題があって、それをね来週直してたらしいです。でGOES-T 今3期目なんですけど、名前のナンバリング今GOES-17まで行ってるらしくて、17の次が18なので GOES-T はうまくいけばGOES-18になる。でイメージセンサー ABI アドバンスドベースラインイメージャーっていうのが日本のひまわりについてるやつの元になってるらしくて、だからひまわりと近いものと思ってもいいと思います。なので日本からねしたらひまわりって結構有名な衛星だと思うんですけど、それのアメリカのやつと思ってもいいぐらいですね。ただ特に観測したいのが地球の大気と、あと雷ってところがとても大事なやつです。はい、アトラス541ロケット。The tour is 58 meters。高さは58メートル。 です。打ち上げ場所が近いという意味です。ごめんなさい。近いって、どっからいや、全然謝んなくてもいいよ。どういう意味で言ったんだろうって気になって。お家から近いのかな。それともあれ40と41が近いとかそういう感じかな。高さ58メーター。54とかじゃないんだね。残念ですね。薄いなのにね。リアは156メーターあるので、全然ちっちゃいですね、この子は。そして総重量が590トン。めちゃくちゃ重いですけど、めちゃくちゃこれ以上重いやつよりは、そんなでもないかもしれない。590トン。まあ、高さの通り、そのぐらいって感じかな。段数は、1段目が、R180。ちょっとね、これちょっとね、気になるんですけど、今後、使えなくなるかもしれませんが、はい、ケロシンのやつ、1段エンジン、そして2段目エンジン、液体酸素と液体水素のエンジンを使っています。これがセントールですね。で、補助ブースターが4本ついてます。4本ついてるんですけど、日本のロケットだとかね、1、2、3、4ってこう綺麗に4つ割りでつけることがあると思うんですけど、この子ね4つ割りじゃないんだよね。ちょっとキモいなんでこんな4ってつけんの。これ2本あるの分かりますか。2本でね、なんかね、デレってついてて、こことここで、あと裏側にもこんな感じでついてて、4つの均等についてるんじゃないんですよね。あとバラバラに分離するっていうのもポイントでしょうか。よし、次。ちょっと時間かかっちゃった。ごめんね。GOES-T が一番上に入ってますね、これ。そして、コメンターペイロードフェアリングがこちらです。そして、ペイロードアダプター。これのところ、今まだついてるので、ごめん、間違った、こっちだ。これのがペイロードアダプターで、この、リングこの CFLR、センターフォワードロードリアクターズ。これもね、ちゃんと外れるの見えたのすごく面白かったね。セントールの前の方の荷重の保持機構、これもすごい。リング、これ見えたの面白かったです。あとセントールがこの子今も飛んでます。で、RC10CE エンジン、これですね。RL10C1 エンジン、そしてここのところがフェアリングとちっちゃいこの細いところをつなぐテールのパーツ、そしてここが弾管部で、こっちのところがブースターとここのアダプターになります。で、10番がブースター。このところが全体でアトラスで、上だけセントールっていうことが多いよ。で、11番が液体ロケットブースター、ここについてもらう。待って、液体じゃない。なんで液体って言っても、固体ロケットブースター、STPB のブースターですね。はい、ソリッドロケットブースターです。で、ここについてる一番下が RD180 のエンジン。これもね、ちゃんとこれからも飛べるといいね。いっぱいついてギュッとアトラスです。このところの分離までは結構早いですね。カメラってどこについてるの？ありがちょう。カメラね、多分ね、この分離がよく綺麗に見えたので、多分ブースターのところに近いところにあるんじゃないかなって思う。こういうところかな。あとね、分離の様子が見えたので、多分この辺の弾管部との間のこの辺りにも1個ついてると思います。この辺と、多分ね、この2段目というか、メインエンジンの根元のところ、このところと、あとブースターの上から見るこの辺の濃い赤角のところなので、この辺についてるっぽいけど、どこの場所についてるのかまではわかんない。もうちょっとでっかい画像とかね、3D モデルがあれば探せるかもしれませんが、これだけではわからないかも。ありがとう。次、飛行計画がね、いっぱいついてます。次の計画が3時間後になるので、結構かかりますね。4時間全部でかかるそうなので、分離まで3時間ですけど、落ちるところまでは、はい、結構かかるので、それぐらいずっと緊張状態ですね。 今は多分バーベキューロールに入ってます。これは ULA さんが出してる資料で、打ち上げのあとどれくらいな感じでどこまで行くのかっていうのが書いてますね。軌道が書いてる。これほら見て。最初ね、静止トランスファー軌道に入るんですよ。静止トランスファー軌道。で、この丸い軌道に入って、近地点、これ近く、遠地点、この遠く、この丸い軌道に入った後、ここの遠くに今ここからキックをして、こっちに行って途中なんですよね。で、この後、この辺の、この青い丸、行きたい軌道と重なる瞬間で、燃焼をもう一回します。これが3時間後になります。なので、今この辺にいるから、ここからこの辺までくるっと行くのに3時間かかるよっていうことになります。わかりやすい。これいいよね。わかりやすくていいよね。この3時間後に、キックして、エンジンをもう一回回すことによって、こっちの水色の方の新しい軌道に入るよっていう感じです。見えてかな。トランスファーオービットとファイナルオービットって書いてますね。トランスファーオービットはこのファイナルオービットに行くための遷移軌道、途中に行くための道、通り道って感じかな。なんか普通のロケットって感じ。ああ、普通のロケット、まあそうね、普通にしてはブースターの位置やばいけど、でもまあスタンダードではあるかもしれないね。なんかさっきごめん、リアが間違って出したやつ、これでも後ですぐ覚えていて、こっちと比べるとね、またちょっと違うよね。っていうのは言いたかったんだけど、こっちはいいや。で、機体の組み立て場所いっぱいあります。これも ULA さんが出しているので、もしよかったら見てみてください。いろんな場所で作っていろんな場所から持ってきてますよっていうのが書いてます。あとは製造場所もね、いっぱい書いてますね。本社がある場所とか、まあいろいろね書いてますね。敵サービスで作ってますよとか、エンジンの一部はねロシアのものを使ってるよとか、そういうのも書いてますし、シスのものもコメントフェアリングついてますよ。これも書いてます。いろんな国の協力によってこのロケット飛んでいるので、頑張ってこれからもロケット飛ばせるような社会だといいね。じゃあここから次を見て終わりにしましょうね。ゴールスティック出してかっこいいもんこれ。ゴールスティックでは、もう一度気をつけようにしてリプレイタイムに行きましょう。はい。Countdown to South Central Engine to start 2 hours 32 minutes and 50 seconds。あと2時間かかるよって書いてるので、これはちょっと眺めておけばいいと思います。このずっとついてるこれをカメラじゃないな、壁紙とかにしとけばいいんじゃないかな。So when is the next RL ignition? Oh, it already says it's there. Yes. And next RL ignition is here. Over 2 hours and 30 minutes. ですね。結構かかりますね。じゃあリプレイタイム and フォトタイム。Let's play a photo. Replay. Wow, Isabella, 9 old? I love NASA. かわいい。でもなんか黒いんやが。I love NASA. 感性がすごい。子供さんかな。木かな。春夏秋冬。違う。四季じゃないな。なんか晴れと雨と砂漠。なんだこれ。 木が黒い何で描いたの？絵の具かな？素敵なイラストでしょうね。これでしょうねじゃないな、なんだ、日本語難しい。素敵なイラストですね。頑張って描いたんでしょうねって言いたかったの。ごめん。素敵なイラストでしょうねってやばいわ。見てわかるよでしょ。さあ、打ち上げをリプレイしていくぞ。
Everybody from a personnel safety standpoint.
And the public really relies on the public broadcasters who come out and give us that information about what's going on. And we have one of the more popular meteorologists that you may have heard of send us a pre-launch message. Take a look at it now.
Instruments.
Did.
Yeah.
He did.
That's all.
Much fan for giving
satellites called.
And we also have a fun game.
For and holding. This is a 30-minute built-in hold where the team is gonna, look at the vehicle and finalize last-minute preparations as we head down to T0
What
this
was the
morning.
longest
So
stream
the
Leo
team's done a
ever
great
did,
job,
and
been
how
on
long
console
was
for
the
several
stream?
hours, and has gotten this rocket ready to go. So looking forward to this.
That shot from the ground there, looking up at the rocket, you can see the skies are blue. We've got some clearing throughout the day. Started off windy and a little overcast, but there you see the clouds moving across the pad. Very light, very scattered. Now we want to tell you where we are. We are in the nerve center of where launch is happening. We're going to turn around our seats, wave at the camera. We're up here on the second level, but down below on the first level is the launch team, and you can see the 3 levels there, the 3 rows. This is where all the action is happening.
Yeah, this is the United Launch Alliance team. This is their launch control center, and Daryl, as you said, this back row that's closest.
He transferred to ULA.
To replace one of 2 GOES satellites already in orbit that together protect more than 1 billion people in the Western Hemisphere.
3, 2, 1. NOAA is about to launch a new satellite into orbit above the Earth. This satellite will be the 3rd in a fleet of NOAA's latest generation of geostationary operational environmental satellites, called GOES, the most advanced weather observing and environmental monitoring system in the world.
GOES-T こんなマシいよ、サイズ的には。Maybe that big volcanic eruption which happened recently. And Tonga? のやつかな？トンガかな？トンガかもしれない。竜巻 and Guesser. I play picture game and like GeoGuessr. My picture guesser Guess what みたいなやつをやったんだけど、あれは結構長かったね。5時間6時間ぐらいやってました。5 hours? 竜巻 also 5 hours.
Western Hemisphere. GOES satellites orbit 22,236 miles above the Earth's equator at speeds equal to
GOES West. これが西半球たら言えんかな？ GOES West, GOES West, GOES East, GOES East. だから、GOES West は西半球を見てるんだよ。西の半分。
Earth's rotation. This allows for continuous coverage of weather systems as they move.
で、こうやって西半球を見てるやつとウエストとイーストの半球を見てるやつの2つでカバーをしてますということですね。アメリカを見たいのでもちろんアメリカをもちろん見たいのでアメリカに対してのカバーですけど、アメリカの東側とアメリカの西側を2つのエリアで見ることによって両方カバーできる。
Throughout the atmosphere, the GOES satellite system keeps watch over more than half the globe, from the west coast of Africa to New Zealand, and from the Arctic Circle to the Antarctic Circle. Each satellite in the series provides high-resolution imagery in near real time to provide critical information, weather forecasts, severe weather prediction, lightning detection, and solar activity.
もう完璧にさっき説明した通りですね。これがソーラー、ライトニングもありましたね。よいしょ。
western U.S. and the U.S. territories. It will provide complete satellite coverage for the weather systems that impact Hawaii and Alaska. It will provide critical data over the northeastern Pacific, where many of the weather systems affecting the continental U.S. originate. It will monitor and track tropical storms and hurricanes in the Pacific Ocean. It will help identify and track wildfires across the western U.S. It will assist in search and rescue efforts around the U.S. and its surrounding waters as part of NOAA's SARSAT system. And it will help monitor and track weather phenomena that impact the western U.S., like dust storms, monsoons, marine fog, atmospheric rivers, and more. The GOES series of satellites supports NOAA's mission to provide secure and timely access to global environmental data and information from satellites and other sources to promote and protect the nation's security, environment, economy, and quality of life.
Otherwise, it's worth about 5.2 times. 持ってみてもらって重いよ。重いかも。確かに。
GOES-T's instruments will gather data that can help in so many different ways, as you just saw. For more on that, let's hear from NASA's Leo Martin.
Thanks, Megan. I'm here with Pam Sullivan, NOAA GOES-R Program Manager. Pam, thanks for joining us today to give us some insight onto this mission.
Oh, it's great to be here. Thanks for having me.
So we've heard that there are 6 advanced instruments on board GOES-T. Can you tell us a little bit about them?
Satellites are improving fire weather forecasts, wildfire detection, and fire hazard tracking in near real time. With lives and property at stake, timely, high-quality data is critical for firefighting efforts on the ground. NOAA's GOES-17, operating in the GOES West orbit, has shown its mettle, detecting and monitoring wildfires and the hazardous smoke they emit.
There's 2 instruments on the GOES series of satellites which are helpful for wildfire detection and monitoring.
Every single day, anytime you open up your phone.
You both are now
control unit armed, the flight termination system armed.
Flight. Go GOES-T.
We can hear the team really picking up the chatter here as we get down to the final minutes for the launch of GOES-T on board an Atlas V rocket from right here at the Cape Canaveral Space Force Station.
Yeah, Daryl, we heard the team, they secured the Atlas tanks to flight pressures, secured that topping. So we see that the liquid oxygen on board that first stage is secure and ready to go. We should be hearing them at about 1:50, securing the Centaur tanks and getting that tank up to flight pressures, getting ready for launch.
Spacecraft is on internal, getting ready to listen to the vehicle.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
So there we hear Daryl, vehicles on internal. The auto sequencer has taken over and started the count. And launch Centaur enabled. LH2 and LOX sequences are done. Launch has been enabled by the launch conductor.
FCS armed.
The flight termination system has been armed. And the team is continuing to finalize all preps as the vehicle is getting ready for liftoff.
120.
FCS count started.
115.
Reduce ECS for launch.
Roger.
110. Vent valves locked.
And there we hear the vent valves locked, securing everything to secure that boil off. We should now be coming up on the last call for the range.
1 minute.
Rock, report range status.
Range green.
And there we have a green range, Daryl, so everything looks good this morning. Last but not least, we will bring everything to flight pressures and then hear that last status check from Dylan Rice.
And that'll be an exciting moment indeed as we look across the river there to a shot of the rocket. Just a few seconds left.
Stable at step 3.
And there we verified that all pressures are good, and we are stable at step 3, ready for liftoff this morning.
28.
Verify ECS reduced for launch.
Verified.
25.
Status check.
Go Atlas.
Go Centaur. Go GOES-T.
And here we go. The final seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Liftoff of NOAA's GOES-T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Daryl, let's listen in as we listen to United Launch Alliance Rob.
Yours look good.
Who's the flight mission commentator?
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We're now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Max Q, 48 seconds.
We have passed through Mach 1. The vehicle is now passing through Max Q, maximum dynamic pressure.
Max Q.
Throttle back those RD-180s.
Now 55 seconds into flight. Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1,900 miles per hour.
Atlas file.
RD-180 is now throttling back up.
これがブースター変なとこついてますよね。
Now at 75 seconds into flight, Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2,700 miles per hour.
Thank you. My YouTube account picture is an Atlas flight as in person.
Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
In 10 seconds, those solid rocket motors on the side will cut off. Beautiful shot from space.
Cut off?
SRBs have burned out as expected, and we see a good SRB jettison.
そしてバラバラで
Clear shot of those
めっちゃ面
SRBs.
白いねこれ。バラッバラよ。ほんと。こんなんでいいんかってくらいバラバラ。
Here in a few seconds, they're going to throttle back up.
Vehicle performance looks good at this time. Now 135 seconds into flight. The RD-180 has throttled down slightly. Vehicle performance continues to look good at this time. Tank pressures are stable and Atlas booster battery voltages remain in their expected ranges. Now the upper stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels.
Now they'll jettison the payload fairing, which protects GOES-T at 3 minutes and 30 seconds.
止めてもいい?
We have just over 1 minute until BECO. We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit. Standing by for payload fairing jettison.
フェアリングってションがあります。フェアリング見て、フェアリング。めっちゃ面白いから。フェアリング
And we've seen a successful payload fairing jettison.
Good shot of those fairings.
RD-180 is throttled back up now.
だって、めっちゃ面白いね。
Vehicle performance continues to look good at this time. Tank pressures are stable and Atlas booster battery voltages remain in their expected ranges.
ゴール17が静止軌道から打ち上げ撮影していた？そうなの？それ
Now
面
the
白
upper
いね。
stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels.
すごい。そんなことあるんだ。見たい。めっちゃ見たい。
Now they'll jettison the payload fairing, which protects GOES-T at 3 minutes and 30 seconds.
We have just over 1 minute until BECO.
明るが長いからめっちゃ見づら
We're
いね。
now seeing
そう
the
調
RD-180
整がし
throttle
づらい。
limiting to maintain a 2.5G acceleration.
It creates a dance with the rocket time. Dancing with the rocket.
Payload fairing jettison.
5-4, 5-4, 5-4, you hey! Go center, 5-4, yay!
And we've seen a successful payload fairing jettison.
Stop! This is fairing and center, forward, system. なんだっけ? Center, forward, road, ring. The ring is めっちゃ綺麗に見えたね。The ring. Half ring. That was ウーブリって何？ウーブリって勉強しないとわかんない単語。
Good shot of those fairings.
綺麗に撮れましたね。
RD-180 is throttled back up now. And the vehicle has reached a 4.6G acceleration limit and will maintain this level through BECO.
And you're looking at animation now.
We've seen that the Centaur has begun its boost phase chill down sequence.
Oh, it's getting a bit late for me now, so oyasumi. Hi, oyasumi, thank you.
And BECO, booster engine cutoff. Standing by for stage separation. And a successful stage separation event. We've seen pre-start on the RL-10. And mass 1, we have ignition for the first burn. This first burn of ULA's Centaur upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes.
What a shot there, huh, Mick?
Yeah, that was great, Daryl, to see all that and listen to Rob Kesselman call that flight. The first stage performed very well this.
We've seen pre-start on the RL-10. And mass 1, we have ignition for the first burn. This first burn of ULA's...
Good shot of those.
ULA's Centaur upper stage.
Booster about to cut off.
And BECO, booster engine cutoff.
このさ、排気のところちゃんとつながってて、ここで切れるんですね。面白い。あと2段目はここにこうつながってて、1段目はこのてっぺんのところ。こんな風になってるんだね。
Standing by for stage separation.
ほら、この真ん中のこれとこれつながってて、でなんか紐みたいなのでピーンってなってる紐。
And a successful stage separation event.
結構筒の中に入ってますね。すごい。いってらっしゃい。
We've seen pre-start on the RL-10. And mass 1, we have ignition for the first burn. This first burn of ULA's Centaur upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes.
What a shot there, huh, Mick?
Yeah, that was great, Daryl, to see all that and listen to Rob Kesselman call that flight. The first stage performed very well this afternoon, and everything's looking good. Those gems.
Reaction control system as it begins its periodic firings to maintain
eruptions. In particular, probably the most spectacular example will be the Tongan. But what we also have is another example in the Caribbean where you can see not only the amount.
Mid-coast phase, Mick.
At this time, the GOES-T spacecraft and ULA's Centaur upper stage are in.
Again, NOAA's partnered with the FAA, and they provide them with those volcanic ash, both forecasts and projections for where that ash could go.
All right, we're now approaching another milestone in the ascent. Daryl and Mick, back to you.
Thank you very much, Megan, and we continue to burn, continue to get good numbers as we monitor the flight of the Centaur.
Beginning the second main engine burn.
Projections for where
Here in about 10 seconds, we'll have the
Standing by
cutoff.
for the end of the burn. And we have Miko. Main engine has cut off.
There you go. That completes that first burn. And so now we go into about an 11-minute coast phase, Mick.
At this time, the GOES-T spacecraft and ULA's Centaur upper stage are in an unpowered coast phase that will last approximately 11 minutes. The coast allows the vehicle to move to optimal orbital position in the orbit prior to beginning the second main engine burn.
Here.
We have ignition. MES 2.
And there we hear pre-start on the RL-10 coming up from Rob Kesselman. Data showing that RL-10 is getting ready to ignite for this second burn.
LOX pre-start on the RL-10. We have ignition. MES 2.
All right, main engine start number 2. We have advanced across the bottom of your screen where we have all the milestones listed. We're going to burn for about 6 minutes. As you mentioned, Mick, this is really hitting the gas
PU
and
has
getting
gone to
out
closed loop
deeper into
control.
space.
Yeah, absolutely. This is going to be the burn where we get GOES-T headed out where it needs to be, and then we'll coast for that 3-hour
Vehicle
period
body rates are stable
to get
during
where
this
we
initial
need
part of the
to
burn.
go, and then get ready for separation. So still a lot to go from here, but this is a very important burn for the mission.
Going deeper into space, approximately 20 Centaur upper stage. You're also looking at GOES-T spacecraft as represented by animation. Just a few seconds left in this burn.
And we have Miko 2, second stage main engine cutoff.
And there you go. We have completed the second burn. Really
RCS is now operating at 100% settling level.
Really got away from the Earth, and now we're cruising.
Now, how many miles above Earth's equator must GOES-T raise to achieve geostationary orbit? Miles? 223 miles. B 2,036 miles. And C is 22,000. Me, 2,236 miles. どれだろう? How many miles above Earth's equator must GOES-T raise to achieve geostationary orbit? C. I don't know about miles. C, I think. C なんだ。C is correct. キロメートルで OK。ねえ、ほんとだよ。マイルズわかんない。マイルわかんない。マイルわかりません。It's okay to kilometer. やったーなんでこんな楽しい企画あるんだね。よし。1キロメートル 1.6 マイル。1 kilometer is 1.6 miles。36,000。なんでオーダーぐらいは変わらないってことかな。1.6 倍。なるほどね。2万マイルが35,000とかなんだ。なるほどね。Thank you。ちょっと取ってくるね。
And welcome back to the Atlas Spaceflight Operations Center here in Cape Canaveral, Florida. I'm Daryl Nail with NASA. Mick Woltman, extraordinaire engineer from Launch Services Program. Thanks for staying with us. We are in the midst of a very long coast phase for the GOES-T spacecraft and the Centaur upper stage rocket, which has been cruising out towards a geostationary orbit. And it all started at 4:38 p.m. Eastern Time with a launch from Space Launch Complex 41. Take a look.
Take a look.
The final seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Liftoff of NOAA's GOES-T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Daryl, let's listen in as we listen to United Launch Alliance Rob.
Yours look good.
Who's the flight mission commentator?
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We're now 33 seconds into flight. Atlas is...
It was a beautiful launch.
Yeah, that was gorgeous. I get excited and thrilled as I watch that each time the liftoff. But as you said, Daryl, we're in this long coast right now, but great start getting Atlas 5 off the pad and GOES-T on its way. That was amazing.
We had a little weather early on. There were some clouds that came over, but then cleared to some blue skies as we lifted off. And now, as you mentioned, we are in the midst of the third moment indeed as we look across. Beautiful shot from space. The final seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And lift off. Liftoff of NOAA's GOES-T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Daryl, let's listen in as we listen to United Launch Alliance Rob.
Yours look good.
Who's the flight mission commentator?
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We're now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Max Q, 48 seconds.
There we verified that all
10 miles downrange distance.
Step 3 ready for liftoff.
Station.
Yeah, Daryl, we heard the team. They secured.
Was GOES-T, our newest weather.
We're now.
And here we go.
3 miles in altitude. Nine miles downrange distance.
Max Q, 48 seconds.
We have passed through Mach 1. Vehicle is now passing through Max Q, maximum dynamic pressure.
Throttle back those RD-180s.
Now 55 seconds into flight. 3 miles in altitude, 0.9 miles. And SRBs have burned out as expected.
これかな。ちょっとあっち。ちっちゃくしよう。セパレーション絶さん。待って。アストロが一緒にこれでセパレーションされてます。あとは
And we see a good SRB jettison.
Clear shot of those SRBs.これでいいんじゃない？こんな感じでかな。はい、楽しかった。楽しかった。
Navigation, closed loop steering.
はい、ってことでお疲れ様でした皆さん。
Here in a few.
Coming up on the last call for the range.
1 minute.
はい、お疲れ様でした。今日は楽しかったですか？リアはなんか楽しかったです。意味わかんないことしたからね。はい、お疲れ様でした。こんなことしてとったっけ？雨水だからね、やっぱ雨水と一緒に撮っとかないと。ありがとうみんな。バイバイ、Thank you。もう寝るね、リア。おやすみ。バイバイ。Thank you。バイ。バイバイ。Thank you. See you next time. See you next rocket time. Bye. じゃあね、ありがとう。Thank you. バイバイ。おう。ありがとうございました。じゃあねー。またねー。Stop! Stop my alarm! Stop. Bye! Thank you, your good button, good like. Thank you, like. ありがとうね、バイバイ。